So this video will be focused on the adrenal hormone. So let's go first with the structure. So it's a retroperitoneal structure which composed of cortex and also medulla. So we have medulla here in the middle, and we have the cortex. And as we know, the medulla has actually come from the neural crest or the actinium. So it's responsible for the sympathetic nervous system, whereby it's contained of the chromaffin cells, which produce the epinephrine and norepinephrine. While the cortex, it's composed of GFR. So we have the glomerulosa layer, glomerulosa fasciculata, and reticularis. But before going further into this, let's talk about this steroidogenesis first. In steroidogenesis, it's very important because the abnormality will be explained easily from the steroidogenesis. And it is not difficult if you can remember this number: 3 beta, 21, 11, and 17. So if you can remember 3 beta, 21, 11, and 17, basically you can easily remember the steroidogenesis pathway. So it starts from the cholesterol. This pathway, I'll sketch it in accordance to the layer itself. The glomerulosa, the fasciculata, and also reticularis. So from cholesterol, it will convert into pregnenolone. And because the glomerulosa layer, it does not contain the 17 alpha hydroxylase, so pregnenolone will convert it into progesterone by beta dehydrogenase. 3 beta dehydrogenase. So 3 beta dehydrogenase from pregnenolone to progesterone, and further conversions. So from progesterone, it will further convert by 21 hydroxylase into the deoxycorticosterone. Let's color this into blue. And from the deoxycorticosterone, it further converts into corticosterone by the enzyme called 11 beta hydrolase. 11 beta hydrolase. So it's here. And from the cortisol, it will further convert into the aldosterone by aldosterone synthase. So as this is what happened in the glomerulosa. So aldosterone will be produced because to go into the fasciculata, it needs 17 alpha hydroxylase enzyme. So So 17-alpha hydroxylase enzyme will further convert the pregnenolone into 17-hydroxypregnenolone. 17-hydroxypregnenolone will use the similar enzyme, which is the 3-beta dehydrogenase, to produce 17-hydroxyprogesterone. And further conversions with the same enzyme, which is 21-hydroxylase, will produce 11-deoxycortisol. And using the same enzyme, which is the 11-beta hydroxylase, it will further convert into cortisol. And this happens in the fasciculata. Now, the 17-hydroxypregnenolone will go further into the reticularis by the help of the enzyme 17-20-lyase and will produce our important DHEA. So DHEA is dehydroepiandrosterone. And DHEA will convert using the same enzyme, which is 3-beta dehydrogenase, to aldosterone. If you still remember this, when we talk about the functions of the granulosa cells and also the luteal cells. And aldosterone will further convert into estrone using an enzyme called aromatase. And aldosterone can be converted into testosterone, which is important in female as well for the libido, by using the 17. We have alpha here, so 17-beta hydrogenase. So 17-beta hydrogenase. The same thing, the same enzyme here, which helps the conversion of estrone into estradiol, which is the most important during the reproductive age. And estradiol can convert into the estriol and fetal DHEA that produced by the fetal adrenal gland will actually stimulate the production of the estriol during pregnancy. And testosterone basically will become more potent if it's converted into dihydrotestosterone using the 5-alpha reductase. So this is what happened in the reticularis. Okay, so looking at this, we can first describe about the hyperaldosteronism, which is the Conn's syndrome. Hypercortisol, it's a Cushing syndrome. And if it's abnormality, if there is a problem with the 21-hydroxylase, this one, we will have a problem with congenital adrenal hyperplasia due to the 21-hydroxylase deficiency. And then if we have a problem with 5-alpha reductase, we're gonna have the 5-alpha. We're gonna have a 5-alpha reductase insufficiency deficiency, which is with the ambiguous genitalia. Due to this, it's a phenotypically a male, but phenotypically female, but genotypically a male. That is 5-alpha reductase. If we have reductions in both aldosterone and cortisol, we'll have the Addison disease, which is the primary adrenal insufficiency. So looking at this, we can have six abnormalities: Cons, Cushing, Addison, CAH, 5-alpha reductase. And also, if we have a problem with the medulla, with the increase of the epinephrine and norepinephrine, we're going to have pheochromocytoma. I'll explain further about all of this in the next video.